Let's take a look at graphing horizontal and vertical lines. They're pretty easy to graph. They're also pretty easy to realize when you bump into it. For example, if you ever see a y that's by itself and it's just equal to a number and there's no x variable in there, then basically it's going to be a horizontal line. It's going to run left to right, even though my line is not perfectly horizontal there. But we'll see that once we graph it. There's two different styles for graphing this type of line. Basically, you could make a little t-chart, and because your x value is non-existent, you can plug in anything you want for the x value. So let's just go ahead and make it negative 1, 0, 1, and let's just throw in a 4. So anything you want the x values to be, because there's no x values. So if you want the x to be a negative 1, that's fine. There's nothing to plug it into that equation. If you wanted it to be 2 million, that's fine because there's no x to be plugged into the equation. But we do know what y is always going to equal for this equation. Y equals 3, no matter what x is. And it's using this idea that lets you be able to have these ordered pairs. Negative 1, when x is negative 1, y is 3. But guess what? When x is 0, y is 3 also. And it's that idea that lets us be able to go and graph it like this. Here's negative 1 on the x value, on the x-axis, positive 3 on the y value, on the y-axis, excuse me. And here's 0, 3. Here's 1, 3. And here's 4, 3. And that's fantastic, you know, that lets you be able to graph it. If you're interested in a slightly faster way, think of it like this. Y is going to be equal to 3, and so you just go to your positive 3 on the y-axis and draw a horizontal line. If you can remember that y equals any number is horizontal, you just go to the y-intercept spot, which would be a positive 3 in this case, and you just draw the line, and it's very, very simple. But if you have a hard time remembering, just remember you can do the XY table. Y is always going to be 3 and just plug in some fake values and then you'll see that's what happens. Let's take a look at a vertical line. It's very, very similar. You can do the exact same thing except for this time the X is going to be 6 no matter what. So let's just put 6 in here. Let's just do 3 points. And let's do negative 2, let's do 4, and let's just do 0. So that way it's in no particular order because there's no y in this equation. Okay, here's your equation. There's no y in it, so it doesn't matter what y is. Plug in any numbers you want, keep them small, make it easier to graph. But the x is always going to be 6. So let's see here. 6, negative 2. 6, negative 2. Here we go. 6, positive 4. And 6, 0. As you can tell, it makes a perfectly vertical line. So let's go ahead and draw the line. And there we have it. That is our vertical line. Another bit of information to go for, though, is that basically vertical lines are said to have undefined slopes. Okay. So if it ever said, hey, here's the slope of a line and it's undefined, no, instantly they're talking about a vertical line. If they say the slope of a line is 0, they're talking about a perfectly horizontal slope. And sometimes I use this idea of you could put in 0x since there's no x there, and we would know that, hey, your y-intercept is at 3, but our slope is 0 or 0 over 1, so we don't move up or down at all, we just move to the right one, move to the right one. But that may not help you too much. Right now, I would just say this. The XY tables are great if you're looking for long-term memorization. If you're looking for a quick way, remember y equals anything is a horizontal um, line, and x equals anything is a vertical line.